All right, so last class we were talking about the TCPIP versus OSI layering thingy. So for TCPIP, Internet Protocol Stack, we have application, transport, network, link, and physical. There's a diagram coming up next. OSI, we throw two extra ones in there, so there's 7 layers, and really what they've done is they've taken this transport layer and split it into 3 pieces. Huh? Oh, it's not on? How long were you going to wait to tell me that?
Just waiting for you to finish your thought.
Because I've been like circling things, and clicking on things, and flipping between slides. So in any case, Internet Protocol Stack. So in the TCP, the IP in TCP/IP is Internet Protocol. So this is what it's talking about. Okay, OSI model is the exact same as TCP/IP. The same stuff is being accomplished. They just split the transport layer into 3 layers: presentation, session, and transport. And you might say that they've kind of taken some of the application layer and put it into the presentation layer, and some of the transport layer and put it into the session layer. So, but the same stuff is happening. So the idea and how these layers work is at any individual computer connection, you have the stack on both the input and the output of that connection. So as something comes in to a computer, so let's say we're traveling this direction on the link, we'd hit the physical interface first, then the link, network layer, transport layer, application. So that's riding all the way up the stack. If the application then took that information and sent a request back out, so for instance, let's say this is a web browser. Okay, so we're getting our reply back for, we typed in, we wanted google.com, send a reply. So the request goes out, it comes back, the web page contents of google.com show up, and that's all riding up this stack. So that's presented at the application. Then we click on a link for the, one of the search results, which then sends a request back out. So it's going to leave the application, transport layer, network layer, link, physical, back out over the internet. So each of those layers, application, this is what you're using on the computer, the actual program, and how it interfaces with the network. Transport layer, process. So this is the data transfer. So this is working with the application layer. So if you have an application behind the scenes, we might open up a socket, and we'll look at that a little bit today. In fact, actually, let's just look at that here real quick. Well, I say real quick, but is it ever really quick? I'll just loop through a couple more times. Kind of like, I like doing this, and we were at California Pizza Kitchen this weekend, and they have one of those revolving doors. I have found I cannot go through one of those revolving doors without going around at least twice. It's an impossibility, and my wife gets mad at me, and she says I embarrass her. I don't get it either. All right, so let's do a, I actually prefer, do I prefer? Yes, I prefer. I don't prefer. I will code in here, but I want to run at the command line. So I'm going to create a new project. When you start dealing with networking stuff, I think using Eclipse starts breaking down a little bit. So we're going to use Eclipse as our coding environment for actually writing stuff, but I'm actually going to run our programs from the command line. I just think it works better that way. So let's see here. So we're going to call this network client. CSC440 network client. Good enough. And then I'm going to immediately create a second project. CSC 440 network client. 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 CSC 440 network server. Okay, let's work on the server first. So we'll create a new class, call this driver. Create our little main method there. And what we want to do just initially is we want to create something called a server socket. And this is going to want us to import java.net, which is a networking package that lives within. Did I?
Yep.
I was testing you. You failed. Well, he passed. You failed.
No, I passed the first one with the projector.
Oh, hold on, I still spelled it wrong. Oh, I didn't spell it wrong in this case. This is here. We'll take the lazy route. This guy possibly throws an exception, so we'll just throw the exception, remain, and not deal with it. Because that's what good programming is all about. Passing the buck. All right. So, in any case, the way the server socket thing here works, if we go back to our diagram, let's see, do I want to do it? So we're talking about this physical link here. Well, let's just pretend these are our two computers here. So this is, I'll just make another slide. I like drawing pictures. So this is us. All right, and this. Well, here, let's say this is server, this is client for our little model. Okay, and we want to have the client request something from the server. So what we'll do is we will have a communication channel going from the client to the server, and this guy is going to request something. All right, then similarly, the server is going to do some processing, whatever it is that it does, and it's going to respond to that request. Okay, so this is a client-server model. This is a computer. This is a computer. In our example here, this is a piece of software running on a computer. This is a piece of software running on a computer. Okay, now, for this model to work, what happens here in the middle, let's get some sort of overlay here. This is all the colors we have. Do I have like some pastels? This will work good enough for what I want.
Click on the little box with the color thing. Make your own color.
Oh, well, this is fine. This is acceptable for what I want to do. Perfect. All right. So, nailed it. It's perfectly symmetric. All right. So everything that's in gray here is the TCPIP stack. You could also say it's the OSI 7-layer stack. Doesn't matter. The OSI is a model. an implementation of that model is the TCPIP stack, which actually takes the 7 layers and turns it into 5 layers, just because. So in any case, everything that's in gray here is following the rules of that stack. Here's our client application over here. So when we go and send something to the server, all the setup that we're doing at the application level is in support of what has to happen beneath that. So when we set it up here at the application level, it's also supporting the transport level. So process data, we don't have to say process twice, process data transfer, so this is TCP UDP. So we're actually doing this in our Java program. Network layer, routing of datagrams from source to destination. Okay, so now this transition, as we go from our application to transport to network, this is when it leaves our program and ultimately arrives at our network card. Okay? Everything that happens in between these is software driven. Everything that happens after that is, let's just say for our example right now, hardware driven. Okay? All right, so now over here in our server socket, what this is doing is it's creating, this is going to be our server program. This is creating something called a socket, which is a communication channel between 2 endpoints. So we can think of this as being a socket connection. This red line is being a socket connection from this computer to this computer. Okay? The reality is that this is a physical line, and traveling over that line is packets of data. Make sense? When we establish the socket connection, we are connecting from here to here over this physical line and creating a stream that is capable of sending packets both directions. All right? So it's kind of like paying a toll, if you will, on the interstate. And then getting in a car that goes on the interstate. The car carries thousands of packets. Good enough. Packets of something. All right, so there's a hardware aspect to this network. That's the physical copper wire or the microwaves or the fiber optic cable, whatever it is. But when we create a socket, we are abstracting at a level above that. It doesn't matter what the medium is. We're creating a dedicated connection between 2 points, okay, and maintaining that connection. Now, the difference between a socket and a server socket is a server socket knows how to listen. So a server socket is required for an initial socket to be created. And I'll kind of show this as an example. So I'm going to say socket connection is equal to ss dot, is it ss dot accept? Yeah, there we go. So right before this, I'll do a system.out.println waiting, and then we'll do a system.out.println connect. And we're going to have to import java.net.socket. All right, so this is all our server is going to do right now. Very simple. We establish a server socket. We print out the word waiting. We eventually accept an incoming connection, and then we print out the word connected. And we do nothing other than that. Very simple server that is completely useless, but proves a network connection. All right, we're going to see this. So what I'll do is, actually in this case, I can run it here. So I'm going to go ahead and hit run, and it just says waiting. Now I said port, here, let me stop this real quick. 1, 2, 3, 4, okay. So what this is doing is this creating a server socket that's going to listen on port 1, 2, 3, 4 of this computer. Okay, this computer has an IP address that also is known as local host. And I'll talk about those two things here in a second. So I'll go ahead and start my server, it's waiting. I'm going to go ahead and open up the terminal. And we're going to go ahead and telnet to localhost 1234. trying to connect, blah, blah, blah. Notice this guy says connected. It accepted, and then we just wrote a server. Done. So not too bad. Similarly, let's see. Let's just do it this way. I'm going to talk about loopback devices for a second. I think this should work. Actually, if this doesn't work, it'll be funny because that means we're blocking traffic from our own computer. Telnet, the IP address 1234. This is the actual IP address of this computer. Localhost is a DNS name for this local machine. This is the physical IP address of this machine. It'll be interesting to see if this works. It does. Okay. So this actually left my computer, hit the wireless router here, and then came right back because the destination was local. Make sense? Okay, but I literally just left my computer with that connection and had it come back. The other way we can do this, just to kind of give you the third model, this is kind of a networking thingy, is I can do telnet 127.0.0.1 which is the port number, and notice that connects as well. This is what's called the loopback IP address. Loopback IP address. So I'll create a quick little slide for this. I'm not going to talk too much about IP addresses right now, but I think most of us know roughly what they are. It's like a unique telephone number that identifies a computer on the internet. So we have host names and IP addresses. A host name is like a friendly version of it. So for instance, I can type in localhost, and that is this computer, the host name of this computer. Localhost is a common TCPIP standard for the host name of the computer you are currently on. Make sense? Just kind of a known thing. Whether you're on a PC, a Mac, a Unix machine, localhost means this computer. A synonym for that is 127.0.0.1. Okay, so somewhere in your computer you're going to have a DNS file that maps localhost to this. So localhost is a synonym for typing 127.0.0.1. Why? Because localhost is easy to remember. For any of you who've ever done any web programming stuff and or set up like a database where you're hosting the database on the same place as your web server is, you maybe put the address of your database as localhost. What you're doing is you're saying you can find the database on the same machine as this program's running on. Okay, so if you ever see that, that's what it's talking about. So these are synonyms for each other. That last thing I had, this is an actual routable IP address. And at this exact moment, these three things are synonyms for each other. But these two are part of the loopback network, meaning it doesn't actually leave the computer. So when if we were to do a traceroute, actually, I should be able to do that. Unless it just blocks it. Like it says it doesn't make sense. There we go. One hop. And we saw before that trace routes are blocked when we try to go off campus, right? It doesn't let us go through using the campus network. But in this case, localhost, notice that I typed in traceroute localhost and see it actually mapped it to 127.0.0.1. Okay, so once again, not lying. And let's see, speed was 0.04 milliseconds for, well, round trip was this. The initial outgoing was this. The initial inbound, the final inbound was this. And there must have been delays in the middle. But in any case, you see very, 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 very fast. This did not leave our local computer. Okay? In fact, probably the biggest slowdown here was the the traceroute program itself. Now, if we do a traceroute on this, I think it should still work based on what we saw before. It's not going to block this because it actually doesn't have to go out far enough. Yeah, there we go. So notice, it's actually funny. It's like weird with how the network works with the Apple stuff. Why do I just get random people? See right now, my terminal says I'm on Melanie's iPhone. It just picks up weird host names on the network and just claims it as its own.
I'm on Rachel iPhone.
Are you?
Yeah, not even Rachel.
PC users don't have this though, so it's your one up. You don't get random. I think it has something to do with Apple has a network protocol called Bonjour, and I think that it's pretty chatty. It's kind of the upgraded version of a really, really, really old technology called Apple Talk, which we'll probably talk about at some point in here, depending on where the slides take us and when I get off on a tangent. But in any case, Apple Talk was Apple's really old proprietary networking protocol. More recently, Apple's proprietary networking protocol is called Bonjour. It allows Apple devices to share stuff and you to share Apple printers with other people, and it's actually the technology that's the what's it called? The AirDrop. That AirDrop is based on.
You need it for iTunes.
Huh?
You need it for iTunes.
You need it for iTunes.
Windows computers need to install Bonjour in order to use iTunes.
Really?
Yep.
Yeah.
Wonder why.
They make you have it.
Oh, interesting. It must be that iTunes has sharing turned on by default. Because when you share an iTunes library in a network, it does use Bonjour to do it. It's possible the plugin on Windows maps between Bonjour and Windows home sharing. Speculation at this point. Otherwise, I don't know why they would force you to, but whatever. Okay, but in this case, we see that here's where the traceroute started. We had 2 hops. Okay, 2 hops. It sent a 52-byte packet, which is the minimum packet size for traceroute. It just says we're pinging this out here. We're sending something that has substance so that we have something to bounce back. But in any case, we saw there was 2 hops instead of 1. So it did leave the computer and then bounce right back. Apparently,
what's the 64 hops max?
That's the it tries to in an event that you have a broken internet. I mean, I think the idea is that you'll never have more than 64 hops between point A and point B. So 64 hops is kind of like where gas pumps turn off at like $75 or $100 depending on, so you don't spill $5,000 worth of gas on the ground. It's that same thing where eventually traceroute will finish. When it hits the 64th hop, when it's stuck in an infinite loop somewhere because it can't leave a router, it'll just die. Let's see. I want to find out who this is.
Brian Mosman.
Connection refused. Okay, well, hold on. Is it running a web server? No. Is it running a telnet server? FTP server? What's the loopback? I need to find out the port for the echo server. TCP port echo reply. Seven. Oh, it's behind a firewall. Nice. All right. Well, so that didn't work. No biggie. In any case, we have our nice little server running here. Okay. So once we get this connection, that means that this socket here that we've named connection holds an open telephone line. Okay, an open data communication line between this program, this running program, and, in our case out here, this server, or this terminal. Okay? So, as an example, if I say scanner input is equal to new scanner connection dot get input stream. So remember when we create a scanner for reading something in from the user, we import java.util. We usually do system.in, which is the input stream associated with the keyboard, standard input. In this case, we're creating a scanner to read from a different input stream. That is the input stream associated with the socket that we just created when something connected to the server socket. All right, so assuming we weren't behind a firewall, somebody could be connecting to this piece of software from Moscow, which is in Russia. Saw some glazed lunch.
Isn't it cold there and stuff?
Probably similar temperature to us right now.
They wear like funny hats.
I don't know if they wear any funnier hats than you might see in like northern Wisconsin.
Oh, that's true. They look warm.
It's 23 degrees in Moscow.
It's what?
23.
It's
warmer.
than here.
Warmer. So it's probably more like Champaign, Illinois right now. I'm guessing Champaign, Illinois is probably in the 20s.
What's it like here in Mequon right now?
12,
Oh, okay. All right.
be my guess. Did I guess right? I'm like a human barometer.
In Champaign.
Champaign is 26, Mequon is 12.
Mequon's 22.
Really?
Yeah.
Yeah, it's like
is
balmy.
20.
Champaign is
20? Oh my gosh, it's like balmy here.
Heat wave.
All right, so in any case, we're creating this scanner for being able to read stuff in from a different input stream than we usually do. Okay, scanner still works the same way. Scanner reads stuff in from an input stream. The input stream we usually use is system.in. This input stream is going to be the one associated with the socket connection that's traveling over the internet, in this case, never leaving this computer. But a socket connection nonetheless, just a very, very short connection. So we're going to read this, and we're going to go ahead, we're going to do a system.out.println input.next line. All right, so this will read something in from the communication channel that we've established and spit it out to the screen, proving that we've actually established a real communication channel. Okay, so it's like we're talking to aliens. It's gonna be awesome. All right, so we got our server. Server's waiting to connect. Now we'll go ahead and telnet to localhost 1234, which is the random port that I just chose. Whenever you write your own servers like this, the ports have to be greater than 1023 is the last illegal port. So 1024 or larger. Because the first 1024 ports are for system utilities. So for instance, we were just looking at there's some standard ones like port 21 is FTP, port 23 is Telnet, port 80 is HTTP, web stuff. So like google.com is the same thing as going to google.com:80. Go ahead.
Is there a limit to how high you can go?
It depends on the operating system. It would be size of integer. Actually, I think in Unix, and this could be dated, it might be different in newer systems. It used to be size of short, which is 65,535 was the highest port. So 0 to 65,535 were the allowable port range. I mean, there's a point where how many programs are going to have running listening on ports? So, so there is a limit. It's just like the limit to the size of an integer or something like that in a language, and it's going to be operating system dependent. All right, so we'll tell that to localhost. We see we're connected. Now it's waiting. It's waiting for me to type something. So I'm going to type in woot, press enter. I noticed it read it in. Okay? That's all she wrote. Literally. I wrote woot, and now it disconnected me. And now we're back to Melanie's iPhone. All right. So that makes sense on the server communication side. All right, now we can certainly write our own client side to this. I'll just do that real quick. We're in our network client, create a new class. We'll call this guy driver. Public static void main string array args, and we're going to say socket s is equal to new socket. Let's see, is it local host and then 1, 2, 3, 4 and a second parameter? Okay. And then we got to throw that exception. Again, good programming practice is to pass the buck. Well, let's just do this right now. So we're going to go ahead and create a scanner. Input is equal to a new scanner. S.get input stream. So this is the input stream associated with our socket. And then we'll have this guy do system.out.println input dot next line. Okay, remember this is the client side of things. So what I'm going to do just to get this started, and this is where I say Eclipse starts breaking down for us because we can't have two runtimes at the same time. Can we? I don't think we can. So, well, let's find out. So I need to start the server first. Probably shouldn't have named them both driver. Server socket. So we'll start the server up. There's our server. So is that guy still running? Oh, it is. That's connected. How do I get to the other guy?
On the top, yeah, a little bit farther right, the blue window thing.
This
yeah,
guy?
click the arrow.
Okay. So, oh, nothing's actually going to come out right now. Let me stop this. All right, so that's the exception we got from Scanner because we tried to read something in that never showed up. So I'm going to go back here to our server. So right now, this guy's trying to read something in, but instead, I'm going to comment these out in our server. So instead of reading something in, I'm going to write something out. So this is what print writer output is equal to new print writer connection dot get output stream. And then we need to import java.io. Ooh. So server will, and we'll see if this works. If not, we'll have to do an output.flush. I'll talk about that in a second. But the server is going to establish the connection. Then we're going to create this print writer, which is the system.out is a print writer. So we create our own version of that. Is it a print writer or is it a print stream? Print writer might be implemented in terms of a print stream. Doesn't matter.
Writer, yeah, it does implement. See.
Ha! See? The whole Java language is memorized. I'm already pretty impressed by the number of parameter things I just remembered. All right. So in any case, we create a print writer to output. We connect it to the output stream associated with the socket, and then the server is going to write over the socket, server is here, which should then be received by the client right here when we say input dot next line. Proof that the server can then also talk back to the client, proving that that socket connection is a two-way interstate, two-way communication channel. All right, so let's get our server running first. Okay. Then we want to get our client running. Ruh-roh. It says connected. So this stuff happened. Let me try to do. Just in case it didn't get through. There we go. Server is here. All right, so our server was waiting, it got connected, and then the server created the print writer, wrote server is here out to the client, and the client received it right here. And that flush thing is because we're using this communication channel, this thing called a socket, for sending strings right now, just because that's easy for us to work with. Well, what's a string? A string is a collection of chars. Well, things that get sent over a communication channel are typically sent as bits, collected in packets. So once we put all this, we are relying on multiple layers here because the socket implementation in Java implements TCPIP sockets. Okay, so it implements that TCPIP stack, or the portion of the stack that's appropriate, all the way up to, but not including the hardware in your computer. Well, because of that, when we try to send a string over that socket, it is doing what it thinks we want, but isn't actually putting the data onto the communication channel because we didn't flush it. All right, so it's the real thing is you probably wouldn't send stuff as strings. You'd send stuff as a byte array over a communication channel, so things are arriving one char at a time, but that's not what we're doing. We're sending it as string, so we have to flush when we're done. Otherwise, the next person that comes in isn't happy. I don't know what we're talking about now. All right, so this is just because we have to right now. This actually puts it out onto the communication link and lets the TCP/IP stack finish. All right, so we've proved two-way communication. Client can send stuff to the server. Server can send stuff to the client. Socket is two-way communication. Fair enough?
Now you want to know what the real test would be?
What's the real test?
If you connected on FalconNet and then provided us your IP address and sent you something.
It shouldn't even have to be on FalconNet.
Would it still work?
Well, here. So this is my server. So I'll go ahead and hit play here so it's waiting. So what you need to do is you need to type in, are you at a terminal?
Yeah.
Telnet one, that. But only one person can do it, so don't. Whoever does it first is going to get the spit bag.
Yeah, I got it.
All right, and it came back to you?
Yeah.
Would you type something too?
Would that
No, I don't think
Oh no, that's from the old. That's the old one. Yeah. What about what?
since like the networks on here, like FalconNet, Falcon Resol, would it matter which one you're on since they're only security differences?
No, it doesn't. It's all the same physical network. So here, actually, several of you who have laptops open, this will be actually an interesting lesson here. So I'll just say while true, because again, infinite loops are also good programming practice. think that actually happens. The longer you've been programming, the worse your habits start getting, but it becomes on purpose. It's the programming version of laziness. Well, I want an infinite loop. I'll just break out when I'm ready rather than just have it running for some reasonable amount of time. So now I'm going to run my server. And what this guy is going to do is, so you're set up to connect again?
Mm-hmm.
Okay. So I'll go ahead and run it. You go ahead and connect. I could just press up. Up,
Two ways you can
enter.
press up.
Did you do it already?
Yeah, I connected.
Oh, okay. Well, I wasn't actually expecting this error, but this is good enough. Okay. So right off the bat, actually here's the problem. We're gonna do this again. I got the error because I tried to create a server socket on a port that was already taken. All right, now do it. Press up, then enter. It'll be nice and quick. So he got a response. Somebody else do it now. You're supposed to memorize it. That. This guy right here. So everybody who has a laptop out can go ahead and try to telnet to that from your command line. So two people have got messages. Who got a message now? Who was number two?
Me.
You?
Yeah.
3? Who got a message? Now, what would happen if 2 of you tried to connect at the exact same time? So, who's in the process of typing in? Don't press enter yet. Well, both of you guys have it saved in your thing, right? So,
Yeah.
hit up on your, but don't hit enter. Actually, there's a third. Abe, you're doing it too?
Yeah, but I'm getting something weird. I'm not getting the response I'm supposed to get.
What are you getting?
Yeah, I did it again.
Usage telnet brackets -4 brackets.
Because you're getting an error message because you didn't use telnet correctly. So use telnet better.
You need this. I typed down exactly.
If I come over there and I find you didn't type down exactly, I'm going to be upset. The error you got is a telnet error.
Yeah, sucks.
It does.
Are you on a Windows or a Mac?
Mac.
So it's telnet space 172.31.237.65 space 1234. What did you mess up?
I got it.
All right. So everybody who's trying to connect, everybody press up on your keyboard so you have it staged. Don't press enter yet, though. All right. So we have at least, what, 3 people?
How do I get out of it now?
What? Didn't you get a response back?
I did, but I'm still connected.
Just hit Control C.
Wait, Control C works?
Yeah, it should.
Yeah.
Nope, it gives me errors. I can't get off your server.
I'll just close the command line and reopen it. All right, so you have it staged. You ready, Abe?
Yes.
Okay. So on the count of 3,
When you say 3,
yeah,
it's not
Before
1, 2,
3
3
or
go.
after 3?
It's
right.
1,
When
2,
I say 3, 1, 2. When I say the 3, you press enter. So have your finger hovering over it. Okay. This is a race. All right. Ready? 1, 2, 3. Who got a response?
I did.
All 3 of you? Tell me how that worked. Could this program handle 3 simultaneous connections?
Well, they definitely weren't simultaneous.
Huh?
They definitely weren't
Well,
simultaneous.
let's say we had 500 people. 500 people who all tried to do it at the same time. Chances are we probably get a couple that would have actually gone simultaneously in terms of when you press enter. Okay? All 500 people would have still gotten a response. They would have still gotten a response. Now, if we want to make this a little bit more interesting,
Do a
some work.
counter. And
So I can do something like for int I is equal to 0, I is less than, actually, let's say 100,000, I plus plus, system.out.println, unreasonably waiting. And I'm actually going to put this after I output. Okay, so get yourself staged again. Okay, so whoever gets there first is going to get the server is here message. And then the rest of you are going to, here, let's. I'm doing a bunch of local I/O, so it's definitely going to take some time. All right. Well, it doesn't matter. We'll know who won.
We don't want to know who gets second place, or we're doing the kind of thing where if you're not first, you're last.
Hold on. I gotta.
If you're not first, you're last.
How do I kill off my? This is why I hate.
If you, yeah, you need to go back to the output thing. That was there.
Yeah, I don't have the little red box right now.
Yeah, 'cause you were- Oh, wait, down on the side.
What's up?
Yeah,
Console?
yes. And then the arrow next to the blue box. And yes, and now you can.
All right.
It hides.
Okay. Are you staged? You ready to go? This is the last thing for today. 1, 2, 3. Who got it?
You get it? I got it.
You got it? Abe, nothing? Eventually, one of you will get it. And then eventually the other one will get it. Because TCPIP forces they reconnect.
Couldn't you just do a counter in there and then assign us like 1, 2, 3, 4 printed at us?
Yeah, you could.
This is more like, now you're just going to have to wait forever.
This is
but-
just,
Yeah.
you know.
No, I get what you're saying. Yeah. So look, I'll just do that real quick. The rest of you can pack up if you want. So your count is equal to 0. So we'll output count plus plus. Get rid of the for loop. All right. Do I have to kill this again? I killed it already. All right. All right, ready? 1, 2, 3.
Dang it.
I got one.
You got 1? Oh, you got 0, 1, 2?
No, I got 3.
3. We have 4 people. Who else is doing it? He doesn't even speak English, he beat you. All right, I'll see everybody on Wednesday.